Hello, so in this video I'm going to discuss the transformations booklet and for transformations we need rulers, pencils and tracing paper. So the first question is a question about a triangle, and that this triangle here, basically what's happening, is going to be reflected in the line x equals minus 1, then it's going to be reflected in the line y equals 1 to give us the new triangle Q, and then when that's done you have to describe the single transformation that maps the P onto the Q. Okay, so let's do one thing at a time. P is reflected in the line x equals minus 1. So x lines go up and down as we know, so we're going to draw a line in here. Then the shape's going to be somewhere over here. And then we're going to reflect it again in the line y equals 1, and y lines go across. So it's going to be reflected in this line to come down here. And then finally we're going to work out how has this shape got from here to here. So we'll do this now. I'll show you the answer for that. Okay, so this is the answer for that question. Here's the initial triangle here. I've drawn the line x equals minus 1 here, and we count this, so that's 1, 2 away, which gets you to here. This is 1, 2, 3, 4 away, which gets you to here, and that P then becomes reflected over here. Then the second part says to reflect that shape in the line y equals 1. There's the line y equals 1. Remember, x lines go up and down, y lines go across. So this shape now is reflected down here. Again, 1 away, so it goes there. Count 1, 2, 3, 4, 5, so that takes you down to here, and so on. So that this P has now become shape Q. Now the last part says describe fully the single transformation which maps P onto Q. Now remember, there are 4 types of transformations. There's reflection, rotation, enlargement and translation. So clearly to get from here to here it must be rotation. Now rotation is the first part of the answer. 180 degrees is 2 turns, so it's 180 degrees. Now, as you know, it can be 180 degrees clockwise or 180 degrees anti-clockwise. Both takes you to the same direction. Okay, so it's not important to write, it's not important to know whether it's clockwise or anti-clockwise, because 180 degrees takes you both ways. We do need to know the center of rotation. So the center of rotation, as we know, is where we put the pencil. And you basically pick a few points, for example, 0, 0, 0, 1. Pick a few points, put your pencil there, trace it round to see if it goes, and of course it actually goes at the point minus 1, 1, because that's where those two lines meet the points of intersection. So the answer is rotation, 180 degrees anti-clockwise or clockwise, about the point minus 1, 1. Okay, here we have a question, just a standard rotation question. Rotate triangle A, which is this triangle here, 90 degrees clockwise with the center O. And I've done the answer here. I'll just bring the answer down. Okay, we can see here's our new shape, and it's been rotated 90 degrees clockwise, which is 1 turn to the right, and the center knot is the origin, so the pencil goes there. So trace it, put your pencil here, move it 1 to the right, and you get it there. So here we have a good question on enlargement. Enlargement by a scale factor of 3. With the center of enlargement 1, 2. So this is a good question on enlargement, and I'm going to show you now how I would answer it and how anybody in my class should answer it. Okay, there's loads of different ways people do enlargement, but this is the way we've been doing it. So basically what's happening is this. We label the triangle that we're dealing with, we put a couple of points. That's A, B and C. Doesn't matter, that could be A, B, C, it doesn't matter. Okay. So what we do is we work out how far away each point is from the center of enlargement. We've marked the center of enlargement. We've been told it's 1, 2, so that's it there. And what we do is we write A, B and C on our table, and this information is how far we are from the center of enlargement. So point A is 2 across and none up, which is this. Point B is 4 across and none up, which is this. And point C is 2 across and 3 up, which is this point here, given this. Not from the 0, from the center of enlargement. What we do then is because it's scale factor 3, we multiply those numbers by 3, which gives us 6 across 0 up, 12 across 0 up, and 6 across 9 up. And what we do is we go to the center again, and this time we count 6 across. 1, 2, 3, 4, 5, 6, not up. We go 12 across. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, none up. And finally we go 6 across, which takes us here, 9 up. We draw the triangle, and this is exactly the new triangle with a scale factor of 3 with the center 1, 2. Now we can double check it. That's 2 boxes, This is now 6 boxes, so it's been increased by a scale factor of 3. So our next question is, our next page is just the title Mixed Transformations. We'll bring that down and we'll go to the next question. So the next question is asking us to describe fully the single transformation which maps A onto B. Now, just to reiterate again, there are 4 types of transformations. There is rotation, there's reflection, there's translation, and finally enlargement. Okay, so when they mention transformations, we must pick one of those 4. Now, let's look at let's look at each one. Rotation means you move shapes round. Okay, clearly that's not what's happening here. Reflection is like a mirror line, so it would be the opposite, the mirror of that. Clearly that's not it. Translation's special now because it's the only one that when you translate a shape, it looks exactly the same. It looks in the same direction, it'll be the same size. That's how you know it's translation. Clearly this last one must be enlargement. So it's been enlarged from here to here. So we need to describe the single transformation that maps A onto B. So let's look at our answers. Put that up there. Take the answers down. Put that up. Okay, now. A lot of work to do to work this out. So we know, for example, it's an enlargement. So let's tell the examiner it's enlargement. Now we look for the scale factor. We count this across and we count these. It's 4 boxes. This is 2 boxes, so it must be a scale factor of 2. It's twice as big. Again, you can check that's 2 and this is 4. So we know it's enlargement of scale factor 2. The hard part is to find the centre of enlargement. And the centre of enlargement is where the points meet. And for this, we must get a ruler and we must join each point. So that point joins that point there. You draw a line through there, up and down. You draw from this point here in the middle. This point here is joined here. Draw a line right through. And this point is the same as this point over here. Draw a line through both sides. And somewhere along the line, all the lines will meet at one coordinate. And that coordinate is your centre of enlargement. So we go across and we realise it meets at the point 5, 6. So centre of enlargement is 5, 6. So we need 3 things. It's enlargement by a scale factor of 2, centre of enlargement 5, 6. Next page is reflecting triangle A and the line x equals 4. So that's the question and here's the answer. Fairly straightforward. There's the triangle. Make sure we draw on the line x equals 4. Remember, x lines go up and down, y lines go across. Count to the line and here it's over here. Okay, here's the initial shape. X equals 4, count the line. The line y equals 4 is here. Remember, what x lines go up and down, y lines go across. The x-axis goes up. The x-axis goes across and the y-axis goes up. So just be clear on that. X lines up and down, y lines across. X-axis across, y-axis up. Okay, so next question is similar to the very first type of question we did, and they're saying, can you take this shape P, reflected in the line x equals minus 1, and then reflected in the line y equals 0, and then describe the single transformation to get you from P to the new shape. Okay, so how about we go at that here, and if you want to stop the video, in the meantime I'll put the answer up here now so you can check it. Okay, so here's the answer. Here's P. Reflected in the line x equals minus 1. X equals minus 1, this line here, takes us over here. Then reflected in the line y equals 0. Remember, y equals 0 is y lines go across. That's the line y equals 0, also called the x-axis. Y equals 0, count here to get to here. And then describe fully the single transformation. Remember, there's only 4 types of transformation. Rotation, reflection, enlargement, translation. Clearly it must be rotation. How many turns? 180. So again, it can be clockwise or anti-clockwise because it still gets you 180, 2 turns. And then find the point of rotation, the centre of rotation using your tracing paper. Trace the shape. Put your pencil at a few points till you find out where it goes, and eventually you'll find it goes to the point minus 1, 0. So correct answer: rotation 180 degrees clockwise or anti-clockwise about the coordinate point minus 1, 0. Next question, fairly straightforward. Rotation. Rotate the shape 90 degrees clockwise about the point 1 minus 1. So 90 degrees is one turn, clockwise is coming round to the right, about the point 1 minus 1. 1 minus 1, which is there. So have a go at that, and I'll show you the answer. This is the answer for it. And you'll find that the new shape is going to be here. Okay, so the next question here is describe fully the single transformation that maps P onto Q. Here's P, here's Q. Of course, we know there are four types of transformations. There's reflection, rotation, translation, and enlargement. So we'll have to work out how have we got from here to here. So if you pause the video for a minute, I'll put the answers up. Okay. So we can see clearly out of the four types of transformation, it must be enlargement. It has to be enlargement, okay? Because it's gone from here to here. Now, that's 2 squares across. That's now 5 squares across, which means that it's a scale factor of 2.5, because 2 times 2.5 gives you 5, so it must be a scale factor not of 2 but 2.5. See where that's 2 across, that's now 5. So 2 times 2.5 gives you 5. Again, we must find the centre of enlargement. Excuse me. Join the corners. That corner goes there. Join the line up and down. Next corner goes the opposite side from here to here. Join the line. And this corner to this corner. And of course that goes through the shape. That doesn't matter. Join the line. And they all meet at the coordinate 0, 0. Okay, so the correct answer is enlargement, scale factor 2.5, centre of enlargement 0, 0. And remember to put those coordinates in brackets. Okay, see where they meet. They'll always meet at a point either down here or the other side. Next question is describe fully again the transformation that maps P onto Q. Well, this one is a great example because clearly this must be translation. As I said before, translation is the only type of transformation that keeps the shape exactly the same. See where this looks exactly the same, it's in the same position, it looks exactly the same, it's facing the same way, it's just moved over. So we know it's going to be translation, so we have to work out first of all the transformation, which is translation, and then we have to work out how we've moved it across with vectors. Okay, so the answer is, I've got it here. It's a translation by a vector 6 to the right and 1 down, which is written 6 minus 1. Now here's how we do it. Pick any point. Pick that point and it has to line to that point. Count the boxes across. 1, 2, 3, 4, 5, 6 to the right and 1 down. We must write it first of all like this. 6 to the right and 1 down. Remember, we always go across before we go up or down. So 6 to the right and 1 down is written as 6 minus 1. Okay, this is a good question. This is a reflection question, but it's a different type of question because this time they've given us the line y equals x, and we know that y equals x is this diagonal line. Okay, so we're going to have this shape and we're going to reflect it in this diagonal line. So I'll put the answer up so you can see it. Okay, so here's how you do it. You must get a ruler and you must actually put it in a diagonal. You must follow the way the points are moving. So this point here is if you can imagine, it's half a square away from the line, so it's going to be the other half here. Okay, if you get a ruler and joined it up, you'd realize that it goes from there to there. This shape here, 1, 2 away, 1, 2 away on a diagonal. Okay, follow the line of the diagonal of the ruler. This one here, 1.5, 1 and 2. Okay, 1 there, 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 and you can see if that was flipped over, that's exactly what it would look like on the other side. Next question, describe fully the single transformation that maps A onto B. So this time we're going from this triangle to this one. Clearly it must be a translation because exactly the same position looks exactly the same. So try and work that out while I put the answer up. We can see that it's a translation by a vector 2 to the left and 4 down. Again, pick your point. I've picked this point here, 1, 2 to the left, 1, 2, 3, 4 down. 2 to the left, 4 down with translation, and that's written -2, -4. Write in the transformation and then the vector to go with it. Okay, next question then is a question about enlargement. First question is asking you to write down the scale factor of enlargement. In other words, how's it got from here to here? And part B is to write down the coordinates of the centre of enlargement. Okay, so have a go at that, and in the meantime I'll show you the answer. Okay, so we know if we count across here, we can see that's 3 squares across and that's 6. So clearly it's a scale factor of 2. Now, the centre of enlargement, as we know, we need to join up the points. So join this point to this point, straight line. Join this point to this point, straight line up and down. Join this point to this point, straight line up and down. And this point to this point, straight up and down. And those lines, folks, will always meet either up here or down here. They'll meet somewhere. They meet at the coordinate 2, 1. So it's an enlargement by a scale factor of 2, centre of enlargement 2, 1. Next question, enlarge the triangle by a scale factor of 2 with 0, 2 as the centre of enlargement, which is this one here. Okay, have a go at that, pause the video, and I'll put the answer up on the next slide. And here we have the answer. Again, because we're enlarging, we need our wee box here. We label this triangle A, B and C. We work from the centre of enlargement, which is the point 0, 2, which is there, mark it. And from the centre of enlargement to point A is 0 across and 1 down. 0 across, 1 down. Part B, again centre of enlargement, 1, 2, 3 across and 2 down. And point C here is 2 across and 1 up. And this is where we get this information. We multiply it by a scale factor of 2. In other words, we multiply these by 2. This now becomes 0 across 2 down. This becomes 6 across 4 down. This becomes 4 across 2 down. And what we do then is we then, straighten this up a bit, from the centre of enlargement again, always from the centre, we plot 0 across and 2 down. 0 across 2 down, which gets to this point here. 6 across 4 down, 6 across and 4 down gets me that point there. And the last one, 4 across and 2 up gets me that point there. I then join the new triangle at those points, and that gives me the new triangle enlarged by a scale factor of 2 with 0, 2 as the centre of enlargement. Okay, this question appears quite a lot in the T5 paper, and they're asking to enlarge this shape here by a scale factor of 2 here. So it's nothing about centre of enlargement. You're not going to cross or up or down. It's just basically making this shape twice as big. Okay, so have a go at that, and I'll put the... Okay, so here we have the answer for this question to do with making this shape twice as big. So I'll just try and zoom in a wee bit so you can see it. Okay, so first part is fairly straightforward. This box here is 1.5, so double that will give you a line of 3. Going up this way, that's 1, which gives you your 2. Now, this, if you can imagine, goes 1 across and 1 up. See how it goes 1 across and 1 up? So it's doubled this here, so it's now going to be like 2 boxes across and 2 up, and then join that line. This line's easy enough, that's 2 across, so that's going to give you 4. Now, this here is 1 across and 1 down, so that's doubled up to 2 across, 2 down. Join that line. There's a wee small line across here, join that across, and then this brings you down, because this is 1, that's 2. Now try that, folks. That's a fairly typical T5 question on enlargement, where they don't ask you to find the centre of enlargement or give you a centre of enlargement. In other words, it's just asking you to draw an obtuse shape and see if you can replicate that. Again, another shape to do with enlarging. So we've got this shape here, and we want to enlarge that by a scale factor of 3. Again, a fairly typical T5 question. Have a go at that there, and I'll put the answer up here now for you to see. Okay, so hopefully you can see that. Again, count the squares. That's 2. Because it's a scale factor of 3, that's now going to be 6. That line is 6. Okay, follow this down. That's 2. So this is now going to be 6 again. Now, this is 1 across and 1 down. So that's now going to be 3 across and 3 down. Join it there. Okay, come down this side. That's 1, which gives you now the 3. That's 1 across, 1 down, which gives you 3 across and 3 down, which gives you there. So you've got this, you've got it as far as here, you've got it as far as here, so then points join up. Okay, have a go with that question, see if you can replicate that shape. And so that brings me to the last question here. Now I thought this was worth doing because again, while it's enlargement, it's a scale factor of a half, which means it's going to be half as big. In other words, it's going to be smaller. So this shape here is going to be smaller than what it is at the minute. It's going to be half the size. And the centre of enlargement is the origin, which is this point 0, 0. Okay, have a go at that. And I'll put the answer up for you now. Okay, and here we have it. Again, for enlargement, very important to have our table. Label this A, B and C. Label the centre of enlargement. The centre of enlargement is 0, 0. So, from the centre of enlargement, always from the centre to point A is 6 across. 1, 2, 3, 4, 5, 6 across. 1, 2, 3, 4 up. Point B is 8 across and 4 up. And point C is 6 across and 6 up. So that's given us this information. We half the number now because it's a scale factor of a half. So we half the numbers. And now what we have is we half these to give us 3A 2U, half this to give us 4A 2U, and half the bottom one 6A 6U to give us 3A 3U. Okay, what we do again, go back to the centre of enlargement, redraw these points. 3 across and 2 up, 4 across and 2 up, and 3 across and 3 up, and we get this triangle here. And lo and behold, it's now half the size of the shape. That was 2 across, that was 2 boxes, this is 1, that was 2 boxes, this is 1. So it was worth doing that. Sometimes they can be smaller as well as bigger. Okay, and for this last slide, I just want to very quickly explain scale factor and particularly area. Okay, now in the T5 questions, sometimes they give you a normal shape. Let's say that's 4 squares across, and I've just drawn this, it's not to scale, that's 4 squares across. Let's say that's 12 squares across. The question might say, okay, what is the scale factor? Okay, so the scale factor from this triangle to this triangle is a scale factor of 3. I think we're all agreed that that's 3. Okay, because it's gone from 4 to 12. That's a standard scale factor question. However, the second part of the question, we have got to be very clear about this. How much has the area increased? Now, the area increased is got to do with double, double. Double, double. And what that means is, whatever the scale factor is, you multiply it by itself. So the scale factor is 3. 3 times 3 is 9. In other words, the area is going to be 9 times as big. Don't get mixed up between those two types of questions. If the question is just asking, what's the scale factor? It's a scale factor of 3. However, if they asked how much is the area increased by, it's 3 times 3. Double, double. Be very careful. If the scale factor in a question was 10, then the area would be double, double, which would be 10 tens, which is 100. Okay, be very clear. That's worth 2 marks in the exam. Be very clear on how to get that, folks, so we make sure we get those marks.